Hello members, and welcome to today's Engaging Experts program, The History and Chemistry of Glass Candy Canes. I'm Roanne Phillips, Membership Manager at the Henry Ford. Throughout today's program, if you have any questions, please submit them using the Q&A located at the bottom of your screen on Zoom. Today, we're actually filming live in Greenfield Village in the Davidson Gerson Gallery of Glass with Glass Shop Supervisor Chris Hofmann. Inspired by our 20-year celebration of the Henry Ford's beloved candy cane collection, today you will learn about the history of glass, colorants used, and the history of cane making specific to the glassmaking process. From sourcing materials to batching and melting, patterning to application, dive deeper into the world of what makes glass, glass. You will also discover details of the historical origins of sugary confections like candy canes and how sugar works similarly to glass. I will now hand it over to Glass Shop Supervisor Chris Hofmann.
Hello, I'm Chris Hofmann, and I've been blowing glass for 22 years and am currently the Glass Shop Supervisor in the Greenfield Village. So the first known glass objects were found in what is now Egypt, or was Egypt, and how long do you think that glass candy canes, or just canes in general, have been used throughout the glassmaking process? So the first known things were these beads, and that's about 2,300 to about 2,100 BCE. And then we also have some core-formed vessels, and these, even though they're hollow, they are not blown. This would have been made using what is known as core forming. And so you would actually take, of all things, animal dung with clay, sculpt it, put it onto a mandrel, and then plunge that into a glass furnace. The decorations would have been applied similarly to what we do by adding bits or wraps of glass around and then feathered and festooned, and then some handles would have been applied. And some other beads have a little bit more detail using some various techniques. And then there are some just other core-formed vessels. So there's a pretty wide range considering a very limited technology. And then you generally see a lot of these blues, yellows, and white. So the blue would have been made using cobalt, and then the white was tin, potentially some lead, and then the yellow is actually lead and antimonite. So moving on, the first known glass recipe is actually Sumerian and is written in cuneiform tablets. So we know that glass was actually widely used throughout North Africa as well as the Middle and Near East. So thinking back to the question of how long do you think canes have been around in the actual glassmaking element, the answer is since the beginning. So if you look at the core-formed vessel, at the lip, and then the one on the right, the two handles, those would actually be kind of the precursor to canes as we would think of them being used in the hot shop today. So there are some examples popping in, and all dating around this area of the vessel on the left. So then for beads, adding all these little dots and decorations, as well as the core of the bead itself, would have been actually applied using a lamp and heated up and then applied to a mandrel and then actually kind of dipped and dappled onto the object to create that pattern. So much like how we would apply the cane to draw the buttons onto our own snowmen luminaries. So moving on to the Roman era, the Romans actually used some canes in a different manner where they weren't still not really using cane how we think of it when it comes to the graphic element. So instead of utilizing it as a long rod, they would cut them into smaller wafers, and then they would fuse those together in a circle and then drape them over a ceramic form to get a bowl. So here are some other examples of some various types of what we now know are marinis, or they call it, the historians call it, mosaic glass. So simply by kind of adding various colors of glass and cores, layering them together, you use different furnaces of varying color, by simply dipping into and out of all of those various colors, using molds to create all of these types of patterns. Is a really extensive way to create glass that is still being used today. So around the turn of the millennium, we actually start to see a little bit more colors appearing and more of the cane that we know that we kind of utilize in the hot shop by adding that longer graphic element along the body of the vessel. And at the same time, we can tell that the refinement of the materials has kind of developed a little bit as there's a little bit more transparency in some of these vessels to the right. So these bowls on the right also would not have been blown, although the first known blown objects were discovered to be around this 50 BC time frame and using ceramic blowpipes. These also would have been made as the slumped method, so they would pour out a patty of this glass and then drape it over a ceramic mold. So even though the materials are developing a little bit more refinement, you still see the evidence of some natural impurities. The blue bowl is actually copper, and then the green bowls would have been iron, and the brown bowl would actually be iron and or manganese, and potentially some sulfur. So after the fall of the Roman Empire, glass didn't necessarily stop in that region, but it kind of slowed down, and Islam and the Muslim world kind of picked up the torch. So they had developed some more refined skill and different types of elements. The vessel on the right is actually ground and cut, much similar to what you would expect from a Baccarat or Waterford crystal. And then as there would have been around the time frame that we actually start to see alchemy at play, and the first known glass treatise is the Book of the Hidden Pearl by Jabir ibn Hayyan in the 8th century. So alchemists would have been making all sorts of different colors and experimenting with various glass using these metal oxides. And alchemy actually had a long-standing relationship with the manufacture of glass, which is, it's the modern form of chemistry. And within that time frame, also in the 8th century, Murano did start to pick back up and kind of get back into the vibe of glassmaking, and actually as kind of how we know it to be the staple glassmaker in the world. So here are some examples of some more Islamic glass, and they started to focus their decoration on the outside by adding various elements with enameling. So the chemistry is basically the same. You would pulverize that, add it to a medium like oil, and then brush it on and refire it to get those patterns. So soda glass was developed around the 1000 time frame and really, really heightened the clarity level that is within that glass. But you still, again, see a lot of the impurities that are present. This would have been iron and manganese, and we can deduce through the Islamic glass, giving it its kind of gold hue would actually have a higher iron and manganese content present. So, for example, if you were to go up to the Upper Peninsula by the Porcupine Mountains and just grabbed a bunch of sand, more than likely you would have a copper-based blue type of glass, even if you were still using a soda glass. So Angelo Barovier, in around 1450, had actually developed the first cristallo. So cristallo is basically clear glass, and it is the most refined level of clear glass that the world has ever seen. It became highly sought after throughout the world, in particular Europe. And excuse me, at the same time, Angelo Barovier would have also produced chalcedonia, which, interestingly enough, that this recipe utilizing copper, zinc, lead, and tin is a direct descendant, or our recipe that we use is a direct descendant of this recipe, as we had actually procured this recipe from an Italian glassmaster who visited the shop back in the early 2000s, and he is descendant from centuries of glassmakers, which I find very, very fascinating. And on top of that, they also developed what is known as latimo, or milk glass, And that helps to kind of pave the way for filigrana or cane as we know it today. So here we have a section of me mixing up some of the batch. So the batch itself is relatively nasty by nature. There's a lot of dust, so we take the time to fully suit up in a Tyvek suit. We also make sure that none of our skin is exposed, so we throw some rubber gloves on, and then because it has a lot of fine particulate and heavy metals, I also want to make sure that my team are wearing full respirator gear and that before we even start to head in to actually mix our batch. So the batch is mostly silica, and you can develop silicosis, which I can go into later if you have that question. And then there's also the soda or potash, and then there's limestone. So back in the back of house, we have our tumbler and all of our metal oxides and raw materials. So basically, depending on what that colorant needs to be, we will weigh everything out via a scale and then add it to the mix and then tumble it. So an interesting thing too is that you can't just add a color here or there to the plain batch or to our color base. The color base and the plain batch are actually completely different materials, and you need to ensure that the glasses are compatible. So by adding copper, you can use just the plain batch, but something more along the lines of, say, a lake, there's a lot more metals that go into that, so potentially you need to add something to that mix or remove something to that mix to make sure that it's all compatible. So here, again, after everything's all weighed out, it will go into the hopper, and keeping fine logs of everything that goes into the mix so that we can kind of relatively track how accurate our mixes are in between every time we melt. So we melt various colors throughout the year, as most of you might know. So here, adding some plain batch to the hopper, and then generally we want to make sure that everything is mixed really well so that all of those colorants are completely integrated into the raw material. So we leave this typically for about anywhere 45 minutes to an hour. So then, after it is all being tumbled, it will be poured out into our hopper. And you can see here, this is our iron green. So you'd think that this material, which, you think of iron, it is indeed red, but after its firing process alongside of all of the other materials within that, it actually does produce a very brilliant green. So with the clarification of the soda lime and cristallo glasses, the development of a lot of those colors really started to develop in depth. So, for example, manganese makes purple, but if manganese is present and you add iron to it, it does create brown. You're not going to get that green that you're looking for because the actual green is being washed out. So that goes for other things like erbium as well as lithia that act as fluxes and clarifying agents within the glass body, but that is where I was mentioning earlier that if you're trying to make one color, you might actually need to reduce that amount of material of the manganese or the erbium or completely remove it entirely in order to achieve, say, an amber or that lake green, kind of blue-green that we melt. Yeah, so I'm personally interested in trying to melt some copper-based red because we have those materials on hand, as cadmium and selenium are kind of really dangerous chemicals to work with, and I do not want to expose my team to them. So around the 16th century, we actually start to see candy canes being consumed almost throughout all of Europe. However, they don't quite have that iconic look that you might think. They would just be plain white sticks of sugar. And because sugar was a luxury, again, typically similar to glass, it would have been associated with the wealthy, as the peasantry would not have been able to afford such objects. And at the same time, filigrana is really being developed by the Venetians in cane making and the application of cane, Interestingly enough, once upon a time, I had taken a glassblowing class at a basically a glassblowers summer camp outside of Seattle with an Italian master, Livio Serena. And while he was doing his demonstration, he's pulling the various types of cane for us, doing his demos, and he speaks to our TA in Italian, and he actually confirms that his family was actually the first to develop the filigrana technique. So I am really excited that I kind of have that connection directly to that history. Another thing that I forgot to mention about the Cristallo is that it is also a longer working, easier manipulated material so that you can start to develop a lot more of these types of high refinements within the craft of glassmaking. And so here we have a video of some color bar. We chop this up. So basically you have your colors melted, and going back to Livio, when he taught me, he had never used color bar before, which is something that is kind of standard practice here in America because we just didn't have all of the glass furnaces to melt all the various colors. And you know, we have 3, but for an Italian factory, that's still not that many. So all of our color bar is held in the garage at about 1,050 degrees Fahrenheit, and various weights and lengths of this color bar stock, depending on the actual color application and pattern, are preheated and then stuck with a gather of relatively fresh glass. You can't remove that glass quickly, otherwise when you expose it to the hotter environment of the reheating chamber, which again is 2,100 degrees Fahrenheit, it would thermal shock and break. So here we are melting and starting to kind of bring basically baking heat into this glass colorant. So you want to make sure that you build that core heat up first before you really start to add all the various colors, and otherwise it just does not pull correctly. So there are elements of kind of baking and cooking. The shorter exposure is more of a pan sear, so to speak, versus being able to kind of really allow that material to sit inside of that reheating chamber. So here the rest of the team are melting down and preparing the colors for application to the white core. So the tin and lead present in the white would actually react with the cadmium selenium in the red. So here I am applying a very thin veil of clear glass to prevent that discoloration. So sometimes people like when the different metals kind of play with one another. This combination in particular isn't necessarily all that pretty. It does become kind of a gray tone. And so once the heat is back to the core again, we flatten it out, and then I will await the team to apply the red. And again, the red that we use is a cadmium and selenium-based red. One thing that I did not mention is that the red, if heated too much, will actually turn kind of a livery brown. So we do have to be careful about the environment and how long we are actually firing that within the reheating chamber so that it stays nice and vibrant. Otherwise, the cane is rendered useless. So here, there are the green stripes. And again, there are numerous ways that you can apply color to create this various form of twisted cane. So the next few heats will be spent to ensure that there are no seams in the glass mass itself. So I'm not necessarily just flattening to flatten it, really trying to squeeze out any of those creases, as when introduced to the clear glass to add more material, all of those creases, because the glass is so viscous, it will not flow and will actually trap air bubbles in those creases. So this is one of the most important parts, and typically this is the part where a lot of people will wind up leaving the shop because they get a little bored of watching us smash it flat 10 times over. So the next layer of clear glass is added, and then we start to round it out. So I could have just started rolling, but for this type of cane in particular, we want that pattern to go out to the edges of the cane as possible. So we rock it back and forth on its edge first before rounding it out to try to displace that material throughout the red side and the white side, trying to expose more of that green. So then, in order to pull it, we create a post. So another dip of glass is taken out of the furnace, and in this case, it is added to a drill for us, and yes, that would have all done by hand way back in the 1500s, but and that's actually how I started. Granted, I was taught by Livio Serena, he's a glass master. So, but with the amount of cane that we actually pull here in the shop, it is really easy to blow out your wrists and forearms, so we will take advantage of the drill, and I don't call it cheating, I call it injury prevention. So that is placed on a stool directly to the right of the reheating chamber, and the rest of the mass is stuck. And full disclosure, that is the most centered I have stuck a cane onto that post all year, which I think is pretty funny. So then I can start pulling the trigger, I hand off the end to my assistant or teammate Grant, and he sets it on a set of rollers and continues to twist. And as we twist, we slowly pull backwards. So the hotter the glass is and the faster you pull, the thinner you make that cane. And we really try to pay attention to the feel of the glass to kind of really see how much it's moving, how everything's stretching out, to kind of dictate the pace that we are both twisting and moving backwards. It does take a lot of time and practice. So ideally, after everything is pulled and stretched, you should get about 2 full bowls, as each cane pull takes about 30 canes the bowls take 30 canes to make. So we ideally get 2 from there. So then we'll chop it free and leave it cool on the floor. And then we'll kind of move on down the line. So at around that 1600 mark in 1670, the first known iconic glass canes would have been used, but they didn't still have their iconic shape just yet. So he had used them to control his raucous and rowdy choir boys, although many of the congregation didn't actually appreciate the sweets in the solemn presence of the Lord. So the choir master got kind of creative and added the shepherd's crook to give it what we now think of as a candy cane. Again, these would have been just plain sugar, and the white is not from any colorant, it's simply from aerating all of that cane, or the sugar. So in here, after the canes have cooled, we take a tungsten-coated set of tile nippers and chop them all to length. Depending on what we're making, we adjust the length, whether it's for a bowl or actually bending the candy canes themselves, and just ensuring that they're all as even as possible. And then after all is said and done, we will bundle them up, sort through them, and ideally we get them to be as even in diameter, as well as kind of syncing up the level of twist amongst the canes themselves. And there you can see some examples of some canes that didn't quite make the cut. So we don't have these in production at all, but you get to see kind of a little bit more of how we kind of go through the iteration process. So in 1674, George Ravenscroft in England had developed lead crystal, which greatly intensified the clarity. So if you can think about cubic zirconium in comparison to a diamond, it refracts way more light, and it is also softer to cut, although I'm sure a diamond's probably harder to cut than a cubic zirconium, but it was all about the brilliance and the clarity of the material itself. So the French and English glassmakers tended to kind of work to flaunt that characteristic, whether it was for magnification or for just the actual clarity's sake, while as the Venetians would have used it to kind of flaunt more colors and start to develop more colors, as well as knowing that the glass was very pliable. You start to see a little bit more kind of heightened decoration and a lot of the bits and handles added to that. And actually, in between then and what we think of candy canes now, the first known actual candy cane in America that was used for a Christmas decoration was from a German immigrant, August Imgard, in 1847 in Wooster, Ohio. So again, they would have been just plain white candy canes, and no stripes or flavoring would have appeared. Bob's Candy, which is now Brock's, would have been the first to actually add the stripe and peppermint flavor. So this shows what that all looks like. It is this really nice amber color, and then using a hook, you would sling that kind of molten sugary mass and pull it and loop it over the hook and pull it and loop it over the hook and pull it endlessly until it actually does turn white. So here we have a, oh, maybe not. There it is. Okay. So there we can see how the candy canes are made, and this would have all been taking place at that time by Bob's Candy and other makers as well. And then shortly thereafter, he kept thinking, he's like, well, this process is pretty laborious. I wonder if we could figure out a way to kind of expedite. And his brother-in-law, Gregory Keller, actually developed the machinery for almost full automation of the process. So here you can see how a lot of this works similar to glass, and how the application of the colors to the candy mass itself are directly tied. And so it is still warm and kind of extruding and twisting the cane. And then you see just a simple little twist, and you have a candy cane. So split to modern day, we have various uses of cane in more modern designs, as well as being able to enjoy some candy canes of maybe a little bit more questionable variety. There you actually do see sardine-flavored candy canes, as well as pizza and brisket-flavored, courtesy of Archie McPhee, and I believe they are based out of the Seattle area, if I'm not mistaken. So if that fits your fancy, that's all you. I'll stick with my peppermint and kind of the more traditional application of glass canes to our candy canes. And that concludes my presentation. I want to thank everybody for tuning in, and if you have any questions at this time, I'd be more than happy to answer. Give us 1 minute while we get that up. So, where do you draw inspiration for each year's candy cane? Well, generally, you think about candy cane, it's kind of a pretty straightforward format, so it's a matter of thinking about what colors go well together, and maybe also taking a little bit more of the historic elements from some of the original filigrana, and then we just kind of start having at it and see what looks good and what doesn't, and we start to filter that out, and then ultimately that goes through a selection process with some of the higher in command here, and then we put it into production. What happens to the candy canes that don't make the cut? Are they used elsewhere? So generally, yes, they are saved, and we are working on developing some new products that might potentially use some more of the scrap ends that is still not really a thing just yet, but you can still use it for maybe jewelry. We don't use that now in that fashion, but if you maybe nudge some of the higher ups, we could potentially start working that out. How many candy canes are made each year? That is a tough thing to approximate, as it's miles and miles and miles of cane that we actually pull, and I cannot remember, but Ryan Thompson, the former glass head, had actually done the calculation on that, how many miles of glass cane that we pull. So it's probably pushing closer into the thousands of canes each year. As we, if you think about it, we generally make, I guess, about 250 candy cane bowls a year, and those are even just the canes that do make the cut, so there's all of the canes that don't make the cut as well. So can you explain more on how you get the hook at the end of the cane. So yeah, so with candy cane itself as the sugary version, the glasses or the cane itself is still pliable, but after it has cooled, we would actually place that inside of the garage, much like we would actually place the color rods in, and then we'd pick it up and introduce it to the reheating chamber, and then kind of slowly work the heat in, and then we actually hand bend all of those candy canes. How long have you been working with glass, and what is your favorite piece that you have created? So I have been blowing glass for about 22 years now, and it's hard to say what my favorite piece is that I've ever made. But one thing that does stick out is that my friend and I, Travis Rohrbaugh, for a show in the Phipps Conservatory at in Pittsburgh, we made a full-scale, partially articulated woolly mammoth skeleton that took 2 full months to actually blow and sculpt. It was then attached to a steel armature and placed inside of the conservatory where a bunch of plant life had gotten to grow around it. It was really, really cool, and it was up for 6 months. Maybe somebody's going to ask where that is right now, and it is still in my friend's basement after the show came down. How long can you stretch the cane's glass? So generally, for candy canes, we do want to keep it within the shop. However, I have seen a video of some folks that participate in what is known as the Glass Olympics, where various universities get together and they go through different challenges. And this seems a little dangerous, so I wouldn't condone doing this ever. But somebody took a gather of fresh glass and sat on the back of a motorcycle, while one person who was stationary grabbed the glass, and the person on the motorcycle just took off and created the thinnest string of glass that you could imagine, thinner than a human hair. And so as long as that mass at one end is hot, you can keep pulling and pulling and pulling and pulling. So it's kind of hard to say, as well as, you have to think about the consideration of like how thin or thick that is as well. Why is it important to have glass blowing in the Greenfield Village? So it is important, as Henry Ford actually wanted to try to figure out a way to create his own headlamps for his vehicles, as well as, and this might be maybe a little bit more unknown, he allegedly, and somebody can correct me on this, it is my understanding that when he visited a glass factory, he had actually seen the production line or assembly line in practice. So generally there would have been a starter, somebody to do the middle portion of the forming, as well as the finishing. So I think he was drawn to glass blowing in general, although that's just an assumption based off of that. And he did realize that maybe it wasn't the easiest thing to do, but he appreciated the history, and of course with everything else that he had amassed here in the village, he was just a geek for all of the history. So he wanted it here, and the Boston and Sandwich Glass Works at that time, well, at least around the turn of the 19th century, was the kind of most prolific glass manufacturer. How does someone become a glassblower in the modern age? School, apprentice, or etc.? So it does kind of depend. You can still go the factory route and learn in the factory. Most glassblowers that I have met all have a Bachelor of Fine Art degree. And so basically it would kind of fall in line with a ceramic department or a sculpture department. And because all of those programs would generally have larger scale gas lines plumbed in for various kilns, and then also the power for all the various heavy machinery for a sculpture department. We do have a few glassblowers who basically just decided they want to do it, and they started working for somebody here in town. And I will say that a lot of glassblowers that typically take that route, because they're in it every single day and they get their hands on the material every single day, typically learn a little bit faster than somebody in the university setting, generally because You think about it, there's a 3-hour class that you're splitting with multiple people in the class, and then maybe you get one full blow slot that you have to split with another individual, maybe 2 if you're lucky. So within the span of a week, you might have a grand total of maybe 3 to 4 hours of blowing glass for the week. And if I always kind of equate it to learning an instrument. You can't learn how to play the piano if you go to an instructor's house and then you go back home and you don't have a piano. There's just no way that you're going to get that good. Our 2024's candy canes still available? Yes, they are in store and online, and we are still continuing to crank them out as quickly as we can for the rest of the year.
Thank you, Chris, for this wonderful program, and we hope you've learned a lot today. I know I have. I'd like to take a special moment to give a thank you to our ongoing supporting partner in membership, DFCU Financial. Members, a reminder that 1 week from today, next Wednesday, November 20th, is our 2nd annual member shopping night. This is an opportunity to see local artisans, some beloved handcrafted items from Greenfield Village, and get your chance at some holiday shopping early with us at this member-exclusive retail evening event. If you're interested and would like to register, please visit thf.org for more information. Registration closes at midnight on November 18th. Thank you again for joining today's program. We wish you a happy holiday season.